Hello there, this is Mardin Yadegar and Michael Escobar. We're going to be teaching you guys how to solve linear equations using the method of substitution. And, as you're looking at the slide, you'll see that I have a little joke. You might not understand it till you're in a little bit of higher math, but if you get it, it's a little bit funny. So what is substitution? Well, substitution is a method of solving a linear equation. You solve it by having one of the two equations that you were given be equal to either x or y. Here's an example. X plus 1 equals 1, or x plus y, equals 1, and x plus 1 equals y. As you might have noticed, in the second equation of the example, x plus 1 equals y. So you've already solved for y. What you need to do is substitute the x plus 1 in for the y in the first equation. So instead of having x plus y equals 1, you'd have x plus 1 equals 1. Can't find my mouse. There it is. So now we're going to solve the problem. Substitute the x plus 1 for the y in the first equation, and you get x plus 1 equals 1. And that's how it will look like after you substitute it in. What you will get after you evaluate, as you see, you have two positive 1s, so what you need to do is you need to subtract 1 from, you have to subtract the 1 from the left side, and you get 2x equals 0. And then you just divide, like you would do for any other equation, and you get x equals 0. But guess what? You're not done yet. And you need to plug the 0 back into the original problem and evaluate. Our original problem was x plus 1 equals y. So if 0 plus 1 equals 1, then you get the answer to y. As you can see, our solution's right at the last point of the power or the slide, and it says you will get y equals 1. So your solution is 0, 1. Let's try another problem. Here we have x plus y equals 11 and 3x minus y equals 5. We do not have a variable solved for in this problem. So first we must solve for one of the variables in either of the problems in this problem. So we have 3x minus y equals 5, and it's a little easier because you just have to add over the y and subtract the 5. I mean, if you want to solve for the variable in x plus y equals 11, that's perfectly fine. That works too. You'll get to the same answer. But I just recommend starting out with the 3x minus y equals 5, and you add over the y and subtract over the 5, and then you have solved for y. So plug in, since you already know what y equals, plug in 3x minus 5 for y in the first equation. So your equation should look like x plus 3x minus 5 equals 11. Sorry, I was experiencing some technical difficulties. So where I left off is what your equation should look like after you have substituted the 3x minus 5 in for the y. So you'll get x plus 3x minus 5 equals 11. Now we have to continue solving the problem, and you evaluate the x plus 3x minus 5 to equals 11 and make it 4x minus 5 equals 11. So from here, what you need to do is you need to get the variables alone, and you can do that by the variable alone, and what you need to do is you need to get the x alone. So you add over the 5. Now when you add over the 5, you get 4x equals 16. Now you have to get the x alone by dividing by 4, and you get x equals 4. And you should not get 4, you should always get 4, because we all know our multiplication tables. So, like I said from the previous problem, you're not done yet just because you have x equals 4. You need to still solve for y. So you plug in 4 for the x, and you get 4 plus y equals 11. Now, you need to subtract the 4 from both sides, just like you would when you're solving a regular equation, and you get y equals 7, and that's your solution, 4, 7. Now why don't you go ahead and try a problem? See what you get. Alright, so we're back now. Alright, so now that you've tried the problem, alright, let's see what you got. The solution is 2, 2, and that's what happens when you work it out. That is because x plus x equals 4. And that's what you should have gotten when you worked it out. And you get 2x equals 4, and then when you divide, you get 2. Plug it back in, you plug the x value in, and that's a 2, and you get y equals 2. So that's your answer, 2, 2. This one's going to be a little more difficult, but I think you guys can do it. Alright, give it a try, and tell your teacher when you're done. Alright, so now you've solved it. Now let's check if you got it right. And if you didn't, it's fine. You're still practicing. You'll get it eventually. I actually had trouble with it when I first began, and so did Michael. 5, 3 is the answer. Now we're going to guide you through it. So you add over the y and subtract the 2 so that you can substitute x minus 2 in for the y in the second problem. Then you substitute the x minus 2 in for the y in the second problem, and you evaluate. 3x minus 2 equals 13. Well, you want to get the variable alone, and what you need to do is you need to add and then divide. So you add over the 2, then divide by 3, and you get x equals 5. Sorry, I jumped a little far ahead. But now you need to finish the problem. Remember, you're not done just because you got one of the values. What you need to do is you need to plug in the x value, which is 5, back into the other problem. You get 5 minus 2 equals y, and you evaluate to get y equals 3. And that's your solution, 5, 3.
Hi, this is Michael, and I'll be walking through a problem with you today. First, x minus y equals 3, and x plus y equals 7. We're going to use the substitution method to solve these equations. First, get it so you get y equals something, and we did it so y equals x minus 3. And then substitute x minus 3 into the second equation so it looks like x plus x minus 3 equals 7. Evaluate to get 2x minus 3 equals 7, and then add over the 3 to get 2x equals 10. You add over the 3 because it's a negative, so you have to add. Then you divide the 10 by 2 to get x equals 5. And then lastly, plug the 5 back into the original problem to make it 5 minus y equals 3. Then, when you have y equals 5 minus 3, evaluate so you get y equals 2. Your answer is 5, 2.